Today, our lecture is about the acrylic fiber. We will discuss the following parameters relevant to acrylic fibers: its origin, manufacturing composition and manufacturing process, physical properties, tensile properties, chemical properties, performance properties, and resistance to acid, alkalis, and UV ultraviolet. In the end, we will discuss about the application and uses of the acrylic fiber. Acrylic fiber is synthetic fiber derived primarily from acrylonitrile, a type of monomer obtained from petrochemical sources. Acrylic fiber is known for its softness, wool-like texture, its durability and versatility, making it popular in various textile and industrial application. It is also considered as substitute of wool fiber. Origin of acrylic fibers were developed in 1940 by DuPont under the brand name of Orlon. They were designed as a wool substitute and became popular for their lightweight, warm, and resistance properties or qualities. Further manufacturing composition of the acrylic fibers are made from polymer of acrylonitrile. As we have also discussed this in initial slides, polymer of acrylonitrile, it means at least 85% acrylonitrile with the remaining composition including common like vinyl acetate, methyl acrylate to improve dyeability and softness and other properties. So the main component is acrylonitrile, that is about 85%. What is manufacturing process? Manufacturing process has different steps: polymerization, spinning, wet spinning, dry spinning, drying, crimping, and cutting. Polymerization: acrylonitrile is polymerized with comonomers to form long chain acrylic polymers. In spinning, acrylic fibers are typically spun using wet or dry spinning. For the case of wet spinning, the polymer solution is extruded into coagulated bath, forming fiber. While in the case of dry spinning, the polymer solution is evaporated by heat to form the fibers. So the wet spinning process, polymer solution is extruded into coagulated bath, while in drying spinning, polymer solution is evaporated by heat to form the fiber. Drying, the fibers are stretched to align the polymer chains, increasing the tensile strength. And the further crimping and cutting, the fibers are crimped for texture and cut into the staple length, uh, made into continuous forms, filament forms. This was the overview process of acrylic fiber: polymerization, spinning for the spinning, wet and dry spinning, drying, crimping, and cutting as per required. Further, we will discuss about the physical properties. While discussing the physical properties, density is 1.17 to 1.2 gram per centimeter cubic, relatively lightweight. Softness similar to wool but softer to the touch. Resilience, good elasticity, resists wrinkling. In the end, heat retention, warm with a good insulation properties, same as wool is also warm fiber. Next, we will discuss about the tensile property. While we're discussing about the tensile properties, these are strength, elongation, and tenacity. Strength is moderate tensile strength, about 2.5 to 3.2 gram per denier. While elongation, it is up to 20 to 30% before breaking, providing flexibility. It is good elongation. Tenacity provides sufficient strength for both apparel and industrial applications. Tenacity and strength are same. Mostly the strength is measured in gram per denier or gram per centinewton per tex. Different units are used. Chemical properties of acrylic fiber resistant to most organic solvent and oils, absorbency, hydrophobic in nature, does not absorb water readily, making it quick drying. As it does not absorb the water, so this property making it ability to quick drying. Static buildup, high tendency for static electricity due to low moisture absorption. Further, we will discuss the performance properties of acrylic fiber. While discussing the performance properties, durability, dyeability, UV resistance, and thermal resistance of the fibers and fabric. Durability resists wear and tear, retaining shape and structure. While for the case of dyeability can be dyed to vibrant colors due to the inclusion of comonomers. UV resistance moderate to good. Resists degradation in sunlight better than other synthetic fibers. Further is thermal. Tends to melt at high temperature and it is not used in heat intensive environment. These were the performance properties of acrylic fiber. Acrylic fiber resistance to acids, alkalis, and UV. Acid resistance, excellent resistance to dilute acid, making it suitable for the acidic environment. For case of alkali resistance, moderate resistance to alkalis, strong alkalis can weaken the fiber. For the case of UV resistance, good UV resistance does not degrade quickly in sunlight, making it suitable for the outdoor use. This property or this resistance, this parameter we have already studied in initial slides. So for the case of acid, it has good resistance to dilute acid. For case of alkalis, moderate resistance to alkalis. For case of UV resistance, good resistance to UV. And applications and uses of acrylic fiber in apparel like sweaters, socks, gloves, and scarves are the wool alternative. As we have discussed, this is also used as a substitute of the wool fiber. In case of home textile, blankets, carpets, upholstery, and outdoor fabrics. For the section of industrial uses, it is used in filters, geotextiles, and reinforcement in concrete. Other uses are craft yarns, outdoor awning, and protective clothing. So, in different areas, the fiber, acrylic fiber or acrylic yarn fabric is used in apparel, in home textile, in industrial uses, and other multiple uses. It has wide applications. Summary: in the end, acrylic fiber is prized for its versatility, wool-like feel, and resistance to wear, chemicals, and sunlight. It has wide application across apparel, home furnishing, and industrial fields due to its performance properties and durabilities. I hope we have discussed different sections of the acrylic fibers like origin, composition, 85% it has acrylonitrile, and we have discussed the process, polymerization, spinning, drying, and wet spinning, and cutting, crimping, physical properties, its density and tensile properties, tenacity, strength, and elongation, its chemical properties, performance properties, and resistance to acids, excellent resistance to dilute acid, and it has good resistance to UV lights, and we have also discussed about the application and uses in used in home textile, apparel, geotextile, and industrial application and other applications. I hope by this lecture your concept about the acrylic fiber will be very clear. We will discuss the difference between acrylic fiber and wool fiber in the next lecture. Thank you, Allah Hafiz. Subscribe for more videos, like and share. Thank you, Allah Hafiz.